Hey, sixth grade. Sorry, I'm going back to this method just for today because I just have to for this one day. So we're looking at lesson 11, deviation from the mean, and we're looking at shooting hoops. So we've got 3 different data sets here where Elena, Jada, and Lynn enjoyed playing basketball during recess. Lately, they've been practicing free throws. They record the number of baskets they made out of 10 attempts. Here is their data sets for 12 school days. So on day 1, they each went up to the line and shot 10 times. Elena made 4 out of 10. Jada made 2 out of 10, and Lynn made 3 out of 10. The next day, they went and did the same thing again at recess. This time, Elena made 5 out of 10, Jada made 4 out of 10, and Lynn made 6 out of 10, and so on. So that's what this whole spread of all these numbers is representing. We're asked to calculate the mean number, the mean. So that's that word we've been working with, the mean number of baskets each player has made, and then compare the means and tell what you noticed. So we need a mean for Elena, a mean for Jada, and a mean for Lynn. So we're gonna have 3 different means. So hey diddle diddle, the median's the middle. You add, then divide for the mean. The last couple days, we've looked at a couple different strategies of what the mean means, what its definition is, but our quickest strategy is to add up all the data points and divide by how many data points there are. So if I look at Elena here, I've got 4 plus 5 plus 1. I'm adding up all of her numbers. Plus 7, plus 2, plus 8, plus 3, plus 3, plus 5, plus 7. So in order to find Elena's mean, I'm going to add up all these numbers. Well, 4 plus 5 is 9, plus 1 more would be 10, plus that 6 would be 16, plus 9 would be at 25, plus 7 would bring us to 32. 2 more would bring us to 34. 8 more would bring us to 42. 3 more, we're at 45. Plus 3 brings us to 48. 5 more brings us to 53. And 7 beyond that gets us to 60. So when we add up all these, 4 plus 5 plus 1 plus 6 plus 9 plus 7 plus 2 plus 8 plus 3 plus 3 plus 5 plus 6, we get 60. But hey diddle diddle, the median's the middle. You add, then divide for the mean. Add, then divide. So we added these all up. Now we need to divide, and what we need to divide by is how many data points there are. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. And actually, even without counting, they told us that. They told us that they did this for 12 days up here. So what I'm going to divide by is 12. I'm going to divide by how many data points they've got. So I'm going to go 60, which was my total here. Divide that by 12. Well, 5 times 12 is 60, so 60 divided by 12 is 5. And you can check on a calculator if you would like, but that's a basic fact that I've got memorized there. So that tells me that Elena's mean, her average, is 5. So it's likely when Elena steps up to the, I almost said steps up to the plate, steps up to the line, that it's pretty likely to expect that she's going to make about 5 out of 10. Now we need to do that exact same process again for Jada and Lynn. So with Jada, all right, 2 plus 4 is 6, plus 5 is 11, 15, 21, 27, 31, 38, 39, 40, 41, 42, 43, 44, 45. Oh my gosh, I hope I just counted that right. This is why I should be writing it down. 8 more would bring us to 53. And 7 more would bring us again to 60. So assuming I counted that correctly, hopefully I did, I'm getting a total of 60 again. And once again, when I look at how many data points I again had 12 data points. So again, I would divide by 12 to get my average or my mean. A to the middle, the median's the middle. You add, then divide for the mean. All right, 60 divided by 12, once again, gives us 5. So Jada has 5 as her average, just like Elena has 5 as her average. So when I check Lynn, 3 plus 6 is 9, 15, 19, 24, 29, 32, plus 5 more, 37, 41, 47, 53, and once again, 60. Man, once again, it was 60, but we had then divide for the mean. Again, there were 12 data points, 12 days. It says they each did it like that, and we can count it up for 12. So again, we have an average of 5. So what do you notice? They all had the same sum, which meant they all had the exact same average or mean. They all had a mean or average of 5. Now, even though they all have an average of 5, when you look across here, their numbers are definitely not identical. We've got Elena kind of going up, then down, then up, then back down again. She's kind of doing this roller coaster. Jada's got her own separate roller coaster going on. And Lynn has a little bit of a roller coaster, although she seems pretty consistent here. 3, 6, 4, 5, 3, 5, 4, 6. Her numbers are at least closer together when I look at that. So what do the means tell us in this context? That's what I had said when I was talking about Elena, in the fact that it is likely, I just spelled that wrong, it is likely that the friends will make 5 out of 10 shots or attempts at the free throw line. Okay, in this context just means the fact that we're talking about free throws or attempts or baskets. So when we're talking about context, we're just saying, okay, what story are we putting along with the numbers on this time? So if we know that they all averaged 5, which means any of them, Elena, Jada, Lynn, they're all likely to make 5 out of 10. That's the average that each one of them is scoring at the free throw line. Well, we're going to need to take that data and do a little bit deeper digging, because their numbers were very different on that chart, and yet somehow they all have the same average. So when I flip the page over and look at Shooting Hoops Part 2 here are the dot plots showing the number of baskets that Elena, Jada, Lynn made over 12 days. So same exact data as we saw here, but now they've put it into dot plot form. On each dot plot, mark the location of the mean with a triangle. Then contrast the dot plot distributions, write 2 or 3 sentences to describe the shape and spread of each distribution. Really wordy, but not hard what they're asking us to do. So, all right, part 1, mark the location of the mean with a triangle. Well, we said the mean for all of them was 5, if I look back. So 5, all right, I'm gonna mark it here, although sometimes they show it above the line. I don't know. I always think of it like a teeter-totter, so it makes more sense to me to put it underneath, but whatever. This person was also at 5, and so was this one. They all had the same average, the same mean there. So then we're asked to contrast the dot plot distributions. Well, when we compare, we look at what's the same. So when we contrast, we look at what's different about them. So this one, we've got a dot all the way down here at 1 and a dot all the way up here at 9. So she's really made almost every possibility. The number of baskets Jada has made, well, there was a time she only made 2 and a time she made 8, but she never made less or more than that. And Lynn, the lowest number of baskets ever made by Lynn was 3, and the highest number ever made was 7. So if you look at where I've highlighted there, you can kind of see this like almost reverse triangle pyramid thing forming where their data sets are closer and closer together. There's less spread across these. So that's what this part is asking. Even though it sounds really complicated, when it says write 2 to 3 sentences to describe the shape and spread of each distribution, well, it gives us room to do that down below. Oh, never mind. I don't know where we're supposed to put that 2 to 3 sentences. Off to the side, I guess. Not really room there. So we could say Elena, her shape is flat like a line. It doesn't really have any peaks to it. It goes that the most she has is 2 of the same there. So she's got some little kind of rolling hills when we look at the shape of her data, but it's pretty much flat and it's got a fairly wide spread here. When we look at Jada, she's got a peak here at 4. If you look at her shape, her highest amount of baskets, or most common amount of baskets rather, was she made four different times. She made 4 out of 10 baskets. So her shape, she's got a little bit more of that, I can't think of the word. When 2 sides are kind of, it's got a peak. That word will come to me. Actually, I'm gonna look back at the summary from the last lesson because I'm pretty sure it's in there. Otherwise, it's gonna drive me crazy. The measure of center. I don't know, maybe it was before that. What was that word? The average, the mean. Oh, phooey, it's just gonna drive me crazy. I know it's in here somewhere. So looking at Lynn has the smallest spread. Her data is all closest together. So the smallest spread. And we've got, again, kind of a peak situation going here. We've got a peak at 6. But it's not symmetrical. There's the word. It's not so much symmetrical in the fact that, like, off to this side, we've got 3 other data points, whereas here we've only got 1. Here, it's a little bit more symmetrical in the fact that there's 2 this way and 4 that way. It's still not perfectly symmetrical. Would mean, like, if there were 3 this way, 3 this way, then it'd be symmetrical. So none of these are really symmetrical. This one's the closest as far as both sides being about the same distance and whatnot, but it doesn't have a peak of any kind. So we're asked then to discuss the following questions and explain your reasoning. So would you say that all 3 students played equally well? All right, equally well. Now, they all had the same mean. They all had the same balance point. They all had 5 as their average. However, these differences in spreads make for a difference in how well I might say that they played. Because even though Lynn down here at the bottom and Elena had the same average, if I was only going to be able to pick one of them to join my basketball team, I would rather go with Lynn. And I would rather go with Lynn because the worst she's ever done is 3 out of 10. I'm more confident in Lynn's abilities to make at least some of the points than I am with Elena. Even though Elena had this one day, this one time where she made 9, she also had a day where she only made 1. She's very inconsistent. I can't rely on or depend on what her numbers are going to be from one day to the next because she's all over the place. 1 one day, 2 another day, 9 another day, 8 another day. Lynn's numbers are all closer together. They're more repetitive with the data that she's getting. So I would say that even though they all averaged the same, I actually think that Lynn was the most consistent and therefore Lynn played the best. Well, that was kind of an accident, but I actually just answered question B in saying that. Would you say that they all played equally consistently? Well, I just said, no, definitely not. Did they play equally well? They all averaged 5, kind of. Did they play consistently? No. Spread out all over the place, getting lucky here, getting unlucky here. This person's got a lot more of that like muscle memory. This is somebody who is a lot more kind of trained up or consistent. If you could choose one player to be on your basketball team on either based on their records, who would you choose? Again, for me, it's Lynn. If you have a reason to choose another one, as long as you can explain that, that's fine. But my reasoning is definitely Lynn based on consistency alone. All right, so that brings us over to the next part here. And I know we're at 15 minutes. I swear, guys, I'm not trying to make these long, but I also don't want to skip stuff. You can always fast forward if I'm going too slow on anything. The tables here show Elena, Jada, and Lynn's basketball data from an earlier activity. Recall that the mean of Elena's data as well as that of Jada and Lynn's was 5. Hey, I did have it correct. They're all 5. Record the distance between each of Elena's scores and the mean. All right, we had actually done this in prior lessons. They just hadn't called it what they're calling it now, which is that today they're calling it the deviation from the mean. To deviate just means to go away from. So deviation just means going away from the mean, from the average, from that balance point. So we have done this before, but now it sounds more complicated. Again, try not to let that vocabulary scare you off though, because it's really not. All right, the distance from the mean. Her mean was 5, her average was 5. So when she scored 4, she was only 1 away from that average. When she scored 5, well, that was her average. So she was 0 away from it. 1 was 4 away from 5. 6 was 1 away from 5. From 5 to 9 is a difference of 4. From 5 to 7 is a difference of 2. From 5 to 2 is a difference of 3. From 5 to 8, also a difference of 3, just in a different direction. From 5 to 3 is a difference of 2. From 5 to 3 is a difference of 2. From 5 to 5 is a distance of 0. And from 5 to 7 is a distance of 2. So we're always going from 5. That was her mean, her average. And we're comparing her day 1 score to her average, 1 away. Her day 2 score compared to her average, well, she scored her average. So she was exactly dead on 0 away. Now we're asked to find the average of the distances on the table. So we're finding the average of our second set of numbers here. This is where this, again, not tricky, but just we get complicated in having multiple steps. And this is the last thing I'm gonna do on this video. So what we're doing here, the average of the distances, so 1 plus 0 is 1, plus 4 more is 5, plus 1 is 6, plus 4 is 10, plus 2 is 12, 15, 18, 20, 22, still 22, 24. So my sum, my total is 24, but you add, then divide for the mean. So we added and got 24. We're going to divide 24 by how many data points? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we're getting an answer of 2. That 2 that we are getting there is what we call the mean absolute deviation, often referred to as the MAD. M, mean, A, absolute, D, deviation. That's why it's called the MAD. And I think that's an appropriate name because it can drive you mad based on the number of steps that it takes to get here. Not hard steps, but just a lot of steps. So Elena's mean absolute deviation, Elena's MAD, was 2. So we've got her actual average, her actual mean, which was 5 that we did back on the prior page. And now we've got her mean absolute deviation, or MAD, of 2. The lesson summary will show you examples of this. They give you a lot of other spaces where you can kind of try this out, but the lesson summary does give you that sample and those definitions. So don't be afraid to look back or double check that stuff before you practice with either the practice problems or Khan or Freckle. Hope all is well. Talk to you soon. Bye, guys.